So, what if the most important number in the universe just doesn't exist? Today, we're going to dive into a really radical idea that challenges something we all use every single day without even thinking about it: the number zero. And it turns out, getting rid of it might just be the key to understanding, well, everything. All right, let's really dig into this. What if zero just isn't real? What if something can't actually come from nothing? And look, this isn't just some late night dorm room philosophy. For a growing number of physicists, this is the starting point for a whole new story of our universe, one that might just solve some of the deepest mysteries in all of cosmology. The writer Victor Hugo had this line: everything is something, nothing is nothing. Sounds pretty simple, right? But in physics, this idea is an absolute nightmare. When our very best theories try to describe the beginning of the universe, they slam into a wall called nothing, a point of zero size that breaks all the rules of physics and has had scientists totally stumped for a century. So, where does this whole nothing idea cause the biggest headaches? Well, it's right at the very beginning. Our standard model of the universe, the Big Bang, literally starts with an impossibility, a moment where everything we know completely breaks down. Okay, so here's the problem in a nutshell. To describe the Big Bang, you have to run the clock backwards until the entire universe is squeezed into a space with zero volume, and our equations require us to divide by that zero. And as you probably remember from math class, that's a huge no-no. You get an impossible answer, infinity. This breakdown point is what we call a singularity, and it's not a real thing. It's a giant red flag from the universe basically telling us, hey, your theory is broken here. So if the problem is the zero, what if we just got rid of it? This leads us to this fascinating new way of thinking, a kind of mathematics that's built for a universe where nothing is ever truly nothing. It's called existence math. The whole idea behind existence math, or EM for short, is that information can never really be destroyed. So when two things cancel each other out, they don't just vanish into an empty zero. No, instead, the event itself is recorded. The math actually keeps a memory of what happened. Okay, so this slide really breaks it down. Normally, you take 5, you subtract 5, and poof, the information is just gone. You're left with a big ol' zero. But existence math says, hang on a second. Instead of zero, you get what's called a void. You can think of it like a receipt for that transaction. It's not a number itself, but it tells you something happened, and a separate ledger keeps a record that a value of 5 was canceled. Nothing is ever actually forgotten. And to make this whole thing feel a little less, out there, existence math uses these really human metaphors. It's kind of like every subtraction leaves a little scar. Or think about paying off a debt. The balance is zero, sure, but the record of that transaction still exists somewhere, right? EM works the exact same way. The ledger is an audit trail, and every void it creates has a story, the story of what was canceled out. Okay, so that's the math. But what happens when you take this strange new no-zero rule and apply it to the entire universe? Well, if our cosmos operates on a system that fundamentally forbids zero, it doesn't just tweak our old theories a little bit, it changes everything. This leads to what's been called the two-calculator solution, and it's actually pretty simple when you think about it. For most of the universe, most of the time, we use the normal calculator. Our standard physics works perfectly fine. But when we get to the cosmic extremes, like the moment of creation, we switch to the no-zero calculator, which runs on the rules of existence math. And its one quirky rule is that it absolutely refuses to ever land on a true zero. And this is the big payoff. If the universe's own operating system literally cannot compute a zero, then the singularity becomes impossible. The universe could get incredibly dense, sure, but it could never, ever reach that infinite breaking point. What this means is that the birth of the universe was probably a smooth process, not some abrupt law-breaking explosion from nothing. All right, so this new math isn't just a cool idea. It's the foundation for a whole new physical theory. It's called Duhon's looping motion, or DLM, and it paints this incredible picture of a universe that is constantly, rhythmically creating itself. So you're probably asking, how does a universe without zero actually work? Well, in this theory, reality isn't some static box that things happen in. Instead, it's generated by a single, fundamental field that's oscillating everywhere, all the time, like a cosmic heartbeat. Because it's always in motion, always oscillating, it can never land on a true zero or a state of perfect nothingness. And with each tiny beat of this field, a new chunk of space comes into existence, and time ticks forward one step. Reality is literally being woven, beat by beat. So, and this is a really cool part, DLM gets rid of that singular Big Bang and replaces it with something called the hydronova. It wasn't a violent explosion in space. It was a powerful, turbulent swelling of space itself, all driven by the energy of that fundamental heartbeat. Think of it as a smooth, gushing expansion, not a chaotic bang from some impossible point.
Okay, I know what you're thinking. This is a beautiful story, a really elegant idea. But is it actually science? A real theory has to make bold, testable predictions. And this is exactly where DLM puts its reputation on the line.
Well, the theory's creator, Jonathan Duhon, makes a pretty bold claim. He argues that DLM is different because it's built from the ground up. See, a lot of other theories need these special adjustments, little knobs or fudge factors that scientists have to tweak just right to make them match what we see. Duhon claims this theory has no such knobs. Its predictions just fall out naturally from one single unified idea. And this is where it gets really interesting. Take a look at this prediction. It's shockingly specific. Neutrinos are these tiny, super mysterious particles that come in 3 types or flavors, and their masses are incredibly hard to measure. But DLM predicts their masses aren't random at all. They must exist in this very specific ratio, roughly 1 to 3.1 to 49. No other theory out there predicts this. If our experiments find this exact ratio, it would be absolutely stunning evidence that DLM is on the right track.
And there's another one. A big one. When 2 black holes merge, they send out ripples in space-time, called gravitational waves. General relativity says these waves should just die down smoothly. But DLM predicts that because space-time is granular, built from those tiny cosmic heartbeats, we should see faint echoes in the signal, ringing out at around 250 hertz. Finding these echoes would be a true smoking gun.
So, when you put all these pieces together, what do you get? What does this new story of reality actually look like? Well, it represents a fundamental, ground-up shift in how we view existence itself. I mean, this slide just says it all, right? The old story on the left is one of a violent, kind of accidental beginning from an impossible point, leaving us with this patchwork of separate forces and mysterious add-ons like dark matter. But the new story on the right is all about elegance and unity. It describes a universe that is constantly, rhythmically creating itself from one simple, repeating motion, with no need for a broken beginning or a messy end. So in the end, this whole idea forces us to ask a really profound question about our own existence. Are we the result of a one-time, inexplicable accident that just sprang from an impossible nothing? Or is our universe part of an eternal, self-sustaining rhythm, a cosmic dance that has always been and always will be? For now, it's a beautiful idea, but pretty soon the evidence might just give us the answer.